Hello students, in this video let us start with the next part of the chapter 10 light, that is refraction. Hope you remember students, at the beginning of the chapter 10 light when I started with reflection in the introduction part, before I started with reflection, in the introduction video I have told you whenever light traveling in one medium, whenever light is incident on any object or surface, three things can happen at the same time. A part of light may bounce back, a part of light may be absorbed, and a part of light may pass through the second medium. Now bouncing back we have already considered in the previous videos. We know that is reflection, related with reflection. And absorption we are not going to study much. So let us study the last part, that is when the light passes through the second medium. Here medium can be air, medium can be water, okay, medium can be glass. So let us consider here with the help of ray diagram, let us try to understand this. Now this is medium 1. Medium 1 can be, let us say, air. This is medium 2. Medium 2 can be anything like glass, water or something, oil, like this. Now here I have considered this is my incident ray which is traveling in this medium and which strikes this line. This line is what? It is a boundary separating the two media, or it is an interface between the two media. So this is an incident ray, although I know that ray is never emitted by a source, always a beam is emitted. So here, although I have drawn ray, but assume it to be a beam. So I have shown here that part of light is bouncing back into the same medium 1. Okay, so I am calling this as reflected ray. This is incident ray. A part of light which reflects back into the same medium, that is medium 1, is reflected ray, represented by this. And let us consider a part of light enters into the second medium. Now when it enters into the second medium, obviously here when it enters and passes through the medium, the second medium has to be transparent. If it is opaque, the light will be absorbed. Now I am considering here the transparent medium so that light can pass through it. Now when light enters into the second medium, part of it enters into the second medium. So it is going to move along the straight path only, but it will be bent. It will change the direction. If it had been the same medium 1, then the light would have travelled along this path, dotted path. Okay, but now as the medium is changed, so the direction is changed. The direction is changed. Let us assume in this case the direction is changed this way. Okay, and if you remember, this dotted line is our normal. This is a point of incidence. So here in the diagram I have shown that when light travelling in medium 1 strikes a boundary separating the two media, part of light gets reflected back and part of light enters into the second transparent medium. But when it enters, in this case I have shown it is bending away from the normal. On the other hand, there I have shown different kind of bending. I have shown that a ray of light is incident, part of it bounces back, as in this case, part of this light enters into the second medium, but there is a difference here. In this case, the light is bending away from the normal. See, this is the normal path. It would have been this path had it been the same medium. Now it is bending away from the normal, but in that case I have shown the ray is bending towards the normal. So in both the cases, we have seen that when light enters into the transparent medium, it bends either away from the normal or towards the normal. This bending of light is called as refraction of light. It means when light enters into second medium and moves, it bends and moves. This bending of light is called as refraction, and we can have a look at the definition of refraction. Refraction of light is the bending of light as it enters from one medium into another medium. Even if you write this much, it is fine. It is definition of refraction, but I have here tried to write a better definition. I have written the cause also for refraction. Now why the light bends? Because the medium changes. And what happens when the medium changes? Speed of light changes, as I have told you before. That speed of light is different in different media. So cause of this bending, cause of this refraction is change in speed of light. So we can write the complete proper definition as this. Refraction of light is the bending of light as it enters from one medium into another medium due to a change in its speed. Or if a short question is asked, what is the cause of refraction? It means cause of bending. It is that light has different speeds in different media. Media is a plural form of media. See in this diagram, this is incident ray, this is reflected ray, and this is refracted ray. Similarly there. Now, this is the angle of incidence, angle between the incident ray and the normal. This angle is angle between the reflected ray and the normal at the point of incidence. I have not intentionally written here r. We know that we generally represent it by small r, and these two angles are equal as per one of the laws of reflection. Now, this angle is what? Angle between the refracted ray and the normal at the point of incidence. This angle is called as angle of refraction. Since in this chapter we are going to concentrate on refraction, so we are not going to consider this reflection part. We will concentrate only on these two parts, incident and refracted. So in that case, I can represent this angle of refraction by small angle r. So in this part of the chapter, if I write small r, it means angle of refraction. I hope this basic definition of refraction is clear to you. Now we have seen these two ray diagrams where in one case the light when enters into the second medium bends away from the normal, while in the other case it bends towards the normal. Let us see how this happens and why. Now in this case, let us consider medium 1 to be glass and medium 2 be air. We already know this, that the speed of light is maximum in vacuum and then little bit lesser in air. And in all other media, speed of light is less comparatively. So when we consider this medium 2 as air, it means here the speed of light is lesser than speed of light in the second medium. So whenever light enters from one medium into another medium, if the speed of light increases, as in this case, then the ray bends away from the normal. On the other hand, consider that case where medium 1 is air and medium 2 is water. In that case, speed of light is more in the first medium and speed of light is lesser in the second medium. So it reduces in the second medium. So when light travels from one medium into another medium and speed of light reduces, then it bends towards the normal. So whether it is going to bend away from the normal or towards the normal, it depends upon the speed of light in comparison to the speed of light in the first medium. Speed of light in one medium in comparison to the speed of light in the other medium. And in this case, wherever the speed of light is more, we call it optically rarer medium. And wherever the speed of light is less, we call it optically denser medium. Here this denser does not have to do anything with that mass upon volume formula for the density. Here simply we say that whenever we compare two media together, wherever the speed of light is more, that is optically rarer medium. Wherever the speed of light is less, it is optically denser medium. So in other words, here we can say glass is optically denser, air is optically rarer. There air is optically rarer and water is optically denser. So always we can remember that whenever light travels from denser medium into rarer medium, it bends away from the normal. When the light enters from rarer medium into denser medium, it bends towards the normal. Or we can say when the light after entering into the second medium, when it bends away from the normal, then the second medium is optically rarer and the first is optically denser. And when light entering from one medium into another medium bends towards a normal, then the second medium is optically denser medium and the first medium is optically rarer medium. So remember, speed of light is more in rarer medium than in denser medium. See, when we consider vacuum with any other medium, we know vacuum is always optically rarer because speed of light is maximum in vacuum and lesser in other media. But whenever we consider air and any other media, excluding vacuum, then air will be optically rarer and all other media will be optically denser. But if we consider any other medium other than air or vacuum and take then some other medium in comparison to that medium, so no medium is absolutely optically rarer or optically denser. Excluding vacuum or air, we can say no other medium is absolutely optically denser or optically rarer. For example, I'll tell you. Suppose if I have glass here and then here I have air, as in this case. Now in this case, this is optically denser medium and this is optically rarer medium because here speed of light is more. Let us consider the other way now. Let us consider here, suppose if I consider water there and glass here. So you should remember that speed of light in water is more than speed of light in glass. So if I take glass here, then also glass is optically rarer and water is optically denser. But now students, what I have told you now, that whenever we have two media, wherever the speed of light is more, that is optically rarer medium. Wherever the speed of light is less, that is optically denser medium. Now we know that if we take any two other media, okay, let us take two media other than vacuum and air. Because if I take vacuum and any other medium, I know in vacuum speed is maximum. So vacuum will be the optically rarer medium and the other medium will be optically denser. If I take air and any other media but not vacuum, then again I know speed of light is maximum in air than in other media. So air will be optically rarer and the other medium will be optically denser. Now let us consider if we choose any two other media, okay, other than air and vacuum, then you can never say that this one medium is always optically denser. Because in one case it may be optically denser, in other case it may be optically rarer. For example, let us see here. In the first case, I have taken first medium to be water and the second medium to be glass. Both are transparent. So ray from water enters into glass and it bends towards the normal. Okay, so it clearly shows that speed of light, whenever it enters from one medium into another and it bends towards a normal, then glass is optically denser and water is optically rarer. So in case 1, water is optically rarer, and let us assume that this is right. So speed of light is more in water than speed of light in glass. Now let us consider the second diagram, where first medium I have taken air and second medium is water. Now we know that air is optically rarer compared to water because speed of light is more in air than in water. So the ray is bending towards a normal. So in second case, water is optically denser medium, wherever in this case, water is optically rarer medium. So you cannot absolutely say any medium is optically denser or optically rarer, because whenever you say this word optically denser or optically rarer, you are comparing that medium with some other medium and you are saying you are comparing their speeds. Okay, as in this case. So you cannot say water is optically rarer or optically denser. It depends which other medium you are choosing. In this case, speed of water is more in water. So this is optically rarer than glass. In that case, speed of light is less in water than in air. So water becomes optically denser media. So please do remember that optically rarer or optically denser depends when we are comparing two media and we are comparing the speed of light in two different media. Wherever the speed of light is more, that medium is optically rarer. Wherever the speed of light is less, that is optically denser. I hope this is a new concept for you, but you have to understand it properly. Now let us see the two laws of refraction. One of the laws of refraction is just similar to one of the laws of reflection. That is, the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. This is just similar to one of the laws of reflection. Only the difference is here we have refracted ray and there we have reflected ray. Okay, I hope this is clear. This is very simple, that incident ray, refracted ray and the normal at the point of incidence, they lie in the same plane, as in this case they are lying in the plane of the boat. Now the other law of reflection, which is also called as Snell's law of refraction, is as follows. This law is given a name, Snell's law of refraction. For a given pair of media, it means we are considering two media and that pair is fixed. For a given pair of media and for a given color of light. Color of light here we have written because the color of light may vary. It may be red, yellow, blue, green, orange. Okay. So here we are assuming that the color of light is not changing. We are using the same kind of light and we are keeping the pair of media fixed as first and second. For a given pair of media and for a given color of light, the ratio of sine of angle of incidence to the sine of angle of refraction is constant and is called as refractive index of second medium with respect to first medium. Now students, you must have studied in your 9th class something about cos. In 10th, in your maths also you have the trigonometric ratios, sine, cos, tan. Always, okay, I will not be teaching you that, but at least I will tell you, this sine is always of some angle or cos is always of some angle. These trigonometric ratios are related with angles. And remember that sine of any angle always lies between -1 to +1. It can be -1, it can be -0 point something, it can be 0, it can be +0 point something and it can be maximum +1. So sine value, it can be between +1 and -1 including these two boundary values also. So here I is angle of incidence, sine of I is having certain value, R is angle of refraction, sine of R is also having certain value. And these two values are between -1 and +1, including these two. Okay, so here no need to study more about this. At least you will study that in maths. I can only explain you this much, that is more than enough. So Snell's law of refraction says that if suppose in this diagram, if I change I, obviously when I change I, it means when I bend it less or more as shown here in the medium 1, then R will change. R will change, but it will change in such manner that this ratio will remain constant. You remember in the laws of reflection we were having the law, when we change I, R will change. In that case R was angle of reflection. R changes, but how it changes? Always equal to I. Always angle of incidence is equal to angle of reflection. Here you see angles are never equal. They are always different. As in this case I have shown where the light is traveling from optically rarer to denser medium, I is having greater value than R. And when light travels from optically denser to rarer, then is R value is greater than I. So when I change I, keeping the color of light constant, keeping the pair of media constant, if I change I, R will change, but how will it change? It will change in such manner that the ratio will remain fixed. Ratio will not change when I change I. So I'll repeat it. Snell's law of refraction states that for a given pair of media and for a given color of light, the ratio of sine of angle of incidence to the sine of angle of refraction is constant, and this ratio which is constant for a given pair of media and for a given color of light, this ratio is called as what? It is called as refractive index of second medium with respect to first medium. And mathematically we express the Snell's law as this. N21, where N21 represents refractive index of second medium with respect to first medium, is equal to sin I upon sin R, where I is the angle of incidence and R is the angle of refraction. In some books, you will, instead of N, you will find this symbol mu. Mu to 1 is sin I upon sin R. Here mu to 1 represents the same thing. Refractive index of second medium with respect to first medium. Remember that this ratio is constant when the given pair of media is not changed. It means if medium 1 is here, let us say medium 1 is air and medium 2 is water, then air and water should not change. They should not be interchanged also. Then, and for a given color of light, let us say color of light is red, then this ratio will remain constant even when you change I. R will change but the ratio will remain constant. But what are the two conditions? One, the color of light should not change. If it changes, the ratio will change. Secondly, the pair of media should not change and even the order should not change. I know it is difficult. Refraction is comparatively difficult when we compare it with reflection, but please revise these topics before you proceed, revise this topic very well. This is the introduction of refraction part. Hope you will understand this well after revising. Thank you.